Hello friends, welcome to the next section, clustering. In this section we'll learn and implement k-means algorithm and KNN algorithm. Now we move on to the first video, k-means algorithm. In this data we're going to split the dataset into an arbitrary number of clusters with the help of k-mean algorithm, and each cluster will be represented by the centroids. K-means is a simple and effective algorithm that can be used to obtain a quick idea of how a dataset is organized. Its main differentiation is that objects belonging to the same class will share a common distance center, which will be incrementally upgraded with the addition of each new sample. Let's first understand the mechanism of k-means algorithm. We start with the unclassified samples and take k elements as the starting centroids. We then calculate the distances between the samples and the first chosen sample, so we get the first calculated centroids or other representative values. After the centroids change, their displacement will cause the individual distances to change, and so the cluster membership may change. This is the first time when we recalculate the centroids and repeat the first steps, in case the stop condition isn't met. The concept of k-means with a practical sample from the very basic concepts. First, we'll import the libraries we need. In order to improve the understanding of the algorithms, we'll use the numpy library. Then we've used the well-known matplotlib library for the graphical representation of the algorithms. In order to generate a dataset, normally a random number generator is used, but in this case we set the samples to predetermined numbers for convenience, and it also allows us to repeat these procedures manually. Let's represent the sample's center. First, we initialize a new matplotlib figure with the corresponding axes. The fig object will allow us to change the parameters of all the figures. Both these, PLT and AX variable names, are standardized ways to refer to the plot in general and one of the plot's axes. So let's try to have an idea of what the samples look like. This will be done through the scatter drawing type of the matplotlib library. It takes as parameters the x coordinates, the y coordinates, size in points squared, the marker type and color. Let's run the code. So we get the graph. Here, the black squares indicate the centers. Let's define a function that, given a new sample, will return a list with the distances to all the current centroids in order to assign this new sample to one of them, and afterward recalculate the centroids. Then we need a function that will build the step-by-step graphic of our application. This is the code to do it. It expects a maximum of 12 subplots, and the plot number parameters will determine the position on the 6x2 matrix. 620 will be the upper left subplot, 621 the following to the right, and so on writing order. After that, for each picture, we perform a scatter plot of the clustered samples, and then of the current centroid position. We proceed ahead and add this block of code. Let's just arrange it. Here, the function, called k-means, uses the previous distance function to store the centroid that the samples are assigned to. Then, to get the sample, we use the bin count method to count the number of samples for each centroid, and by building a divisor array, we divide the sum of a class elements by the previous divisor array. Now it's time to kickstart the k-means process, using the initial samples and centers we set up at first. This is the line to do it. When we run this code, we get this result. This plot depicts the clustering process with the centroids represented as black squares.